Hey guys, sorry I can't be here today. Like I said, I was feeling a little under the weather yesterday and figured it'd be best for us all if I'm not there. Anyways, today we're going to talk about 5.2, which is continuing on with verifying trig identities and specifically with the simplifying expressions part. So I'm going to work through these examples that are on here. Feel free to pause at any point in time. I'll probably just work through them pretty quickly. So pause, review, all that kind of stuff you need to do. So here we go. This first one, you can see it says simplify until there are no quotients. So in order to do that, we're probably going to need to distribute to start off here. So we've got cosine x times secant x plus cosine x times cosecant x. You know that secant can change into 1 over cosine. You know that cosecant can change into 1 over sine. Okay? So cosine times 1 over cosine is just going to be 1. And cosine over sine is going to be cotangent. And you would be able to stop at that point. There's no quotients. You've simplified it as much as you need to. So hooray. Next example. You may want to try to find a common denominator here, but I would urge you to not do that. Because notice we've got 4 different trig functions here. We've got cosine, secant, cosecant, and sine. So we want to work with as few trig functions as possible. So what I'm going to do is change secant to 1 over cosine. And I'm going to change cosecant to 1 over sine. In order to cancel those out, we would need to multiply by the reciprocal of the denominator. So I'm going to multiply by cosine over 1, cosine over 1. Over here I'm going to multiply by sine over 1, sine over 1. So the nice thing is that the denominators completely cancel, which is what we wanted. We wanted to take care of the denominator as much as possible. In the numerator right here, you're going to have cosine times cosine, which is cosine squared. And over here, you're going to have sine times sine, which is sine squared. And remember, we have a Pythagorean identity that says cosine squared plus sine squared equals 1. And so that would be simplified as much as you can with no quotients in the final result. All right, third example here. Now your directions change a little bit. It says you simplify it to the point where you have a constant, which would be just like a number like 3, so on and so forth. A single function, which would be like sine x or cosine x or any of the trig functions, or power of a single function, which would be like cosine squared x or any other trig function squared or cubed or the 4th power, anything like that. So on this one, when you're looking at it, you're going to want to change cotangent into cosine over sine. You've still got a sine here, and you notice those cancel, leaving you just cosine x. So that's fancy. Next one is going to have the same set of directions, but it's got a lot messier trig functions in here. So again, my first step is usually to change things into sine and cosine. So I'm going to have 1 over sine x from the cosecant and 1 over cosine x from the secant. I'm going to put those over cosine x over sine x. Again, fraction within a fraction. So in order to take care of that, I'm going to multiply by the reciprocal, the denominator, sine x over cosine x, sine x over cosine x. It took care of what it should have. Those all cancel. Notice in the numerator, I've got a sine and a sine that cancel as well. So all I'm left with is 1 over cosine. Cosine times cosine is cosine squared x. All right, so what's 1 over cosine? Secant. So secant squared is your final answer on that one. Again, these are just a variety of examples of the types of things we could run into. So number 5, there's like a really easy way to do it and a not so easy way to do it. The really easy way to do it is to remember that we've got an identity that says 1 plus cotangent squared equals cosecant squared. If you manipulate that by subtracting the 1, then you get cosecant squared x1, which is what we have on the left. So that is equal to cotangent squared. And then you're done. If you didn't take that approach, the other thing you could do is change this into 1 over sine squared. And then you could find a common denominator. So common denominator for this whole thing would be sine squared. And on the left, you wouldn't need to do anything because it's already 1 over sine squared. On the right, you would need to multiply by sine squared over sine squared, which would make that sine squared. 1 minus sine squared, again, is a manipulation of one of our Pythagorean identities. That would turn into cosine squared over sine squared. Because remember, we've got cosine squared plus sine squared plus sine squared equals 1. So you could subtract the sine squared over, and then it's equal to cosine squared. Anyways, cosine squared over sine squared is yay. Either way, both ways work. So that's one of the things that's tough about this chapter is there's lots of options. That's it. That's your assignment. Don't be a pain for the sub. Sit there and work on it. Don't watch YouTube or play Slope or other strange little computer games. Just work on the assignment. Take care of business. Be an angel for the substitute. And that's all I got. Peace out.